On the basic question, says to make the scatter plot of the data, and what the data is the question is asking, do heavier people burn more energy? So along the x-axis, I ran the masses of the heavier people going up, and then on the y-axis, I put the metabolic rate, and so this shows the scatter plot for that, and it's mostly a linear type scatter plot. It has a strong positive correlation. As mass goes up, rate goes up as well. So for B, so I said the scatter plot was a strong positive correlation, and the scatter plot shows that mass and rate of metabolism are very related, so they are correlated. So next up is the advanced question, and in the advanced question, it's asking, or the background of it is a representative age and how fast their walk distance is in 6 minutes. And so the first thing you had to do was determine the least squares regression line and interpret the meaning of its slope. So the regression line's right here through the middle, and it's predicting where the points will fall on the scatter plot. And its slope is primarily linear. And so with that linear slope, it also shows right here the residuals are scattered everywhere. So the residual plot and then the scatter plot together show that it's a linear type graph. And so then, so that is A and B for the first one. This is the equation that can predict the slope for the residuals. And then here's the AP question. So the AP question says, commercial airlines needs to know the operating cost per hour of flight for each plane in their fleet. In a study of the relationship between operating cost per hour and number of passenger seats, investigators computed the regression of operating cost per hour on the number of passenger seats. The 12 sample aircraft used in the study included planes with as few as 216 passenger seats and planes with as many as 410 passenger seats. Operating cost per hour ranged between $3,600 and $7,800. Some computer output from regression analysis of these data is shown below. So, A in the AP question asks, what is the equation of the least squared regression line that describes the relationship between operating cost per hour and number of passenger seats in the airplane? So, if you look on this sheet, you will see the constant of the coef is 1,136, and the seats are 14.673. So you can predict the numbers of the equation by plugging in your constant and then the variable of the seats that different amounts of people can buy different amounts of seats. So you're for sure going to get a 1,136, and then depending on the amount of people that buy seats, the second number can vary. And then, so for B on the AP question, let's see. Oh, whoops. So B on the AP question asks, what is the value of the correlation coefficient for operating cost per hour and number of passenger seats in the plane? So for this, you calculate the residual squared, and you get that it's about 0.57. So with the residual squared, to find the R value, you take the square root of 0.57, and that leaves you with 0.75498. So that would be the correlation coefficient that helps describe the relationship in the scatter plot. So for part C on the AP question, it's asking that you want to describe the relationship between operating cost per hour and number of passenger seats in the planes for planes only in the range of 250 to 350. So down here you see the 200 and the 300. So you're taking from this range and this range. And if you look, the least squared regression line really is not going to be the most efficient way to measure this, because the data in this range seems much more scattered than linear. So the line is not a good predictor of where the data will be, considering how scattered and unorganized the data is. And that is my quideo. Thank you for listening.